Today's forecast, a tornado warning is in effect. Swarms of gigantic twisters over a wide area, with winds topping 6,000 miles an hour. Luckily, you live outside the danger zone, because these twisters are found in space.
With winds of 300,000 miles an hour.
What would happen if a tornado that powerful struck a city on Earth?
It just goes poof, and it's gone.
They're tornadoes to the max on deadliest space weather. Earth's is just one kind of weather. On other planets, there are storms beyond the imagination, climates and conditions that we hope to never see on Earth. But could they happen here? And if so, could we survive deadliest space weather? It's late spring in the Lone Star State, peak tornado season. On this day, a monster twister descends from a giant thunderstorm. The immense funnel is 3 miles across. One of the most populated cities in Texas is in its path.
As this tornado moves towards Dallas, Dallas is going to experience something more powerful than anything that it could have imagined. About a quarter of the city will be laid waste.
The winds in this freak storm rage at 500 miles per hour.
One of the most startling sights we'd see is the destruction of the distinctive Reunion Tower. The top of it is going to just get blown off. It just goes poof, and it's gone. The tower itself would be pushed off its foundation and would likely fall all in one piece.
Fortunately, a tornado this big will never strike Dallas. This monster is what scientists think could be hiding on a newly detected world, strikingly similar to our own.
This is a planet that's about 1.5 times larger than the Earth in its physical size, and it's located at a distance from its parent star, which is very similar to the distance that the Earth is located from the Sun.
In early 2013, Kepler spacecraft scientists announced evidence for this super-Earth 2,070 light-years away. It may be the most Earth-like planet yet found.
We can imagine that it has continental areas that are flat and subject to strong cold fronts, as well as a warm, low-latitude sea that can provide masses of humid air. And so if those conditions exist there, then the conditions for strong tornadoes would also potentially exist.
The new planet might also have more tornadoes. Earth has 4 seasons due to the tilt of its axis. Most tornadoes strike in the spring when the sun heats the planet more or less evenly. If super-Earth has little or no tilt, it would have no seasons, with spring-like conditions all the time.
Without seasons, you might have the potential to build tornadic storms year-round. And so rather than just one of 4 seasons, maybe you have all 4 seasons that are capable of producing tornadoes.
On Earth, the maximum clocked tornado winds are about 300 miles an hour. We don't know the details of super-Earth's climate, but with the right balance of heat and atmospheric water, it's quite possible it could have super tornadoes as well.
Running the numbers on a back-of-the-envelope kind of way, we can imagine tornadoes that are perhaps 2 or 3 times larger in physical size than the most damaging tornadoes that occur here on Earth. The wind speeds could potentially get up to the kinds of speeds that a passenger airline travels at. They could potentially get up towards 500 miles per hour.
But are Earth-like planets the only ones with tornado potential?
Any planet with an atmosphere could have a tornado. All you need are some swirling winds, some energy concentrated in a swirl, and you can get a tornado-like phenomenon.
The planet Mars is home to tornado-like dust devils, swirling vortexes of winds that create columns of powdery debris zipping across the bleak landscape. Earth has its own dust devils. They reach a maximum height of 2/3 of a mile. On Mars, the biggest were thought to be 6 miles high, until a discovery in 2012.
The Mars Reconnaissance Orbiter shocked astronomers because it located a gigantic dust devil 12 miles tall.
But this dust devil was very narrow, 70 yards in diameter. NASA described it as 3/4 the size of a football field.
Imagine yourself sitting in a football stadium, and you've got this tornado 3/4 of the width of the stadium, and it's going up 12 miles high. So if you were to just go up, it would keep going and going and going. A very narrow, very high, swirling tornado of dust.
The solar system's giant planets might also produce tornadoes. Jupiter, Saturn, and Neptune are already known for their swirling clouds and hurricane-like storms. On Saturn, the Cassini spacecraft captured a photo of the planet's southern polar region, showing some twisted clouds that look familiar. They are intriguingly similar to the Doppler radar hook echoes that are said to be signatures of tornadoes inside supercell thunderstorms on Earth.
I wouldn't be a bit surprised if one day we can nail it and say that this is in fact a tornado on Saturn. But right now our instruments are not fine enough to make that conclusive judgment.
The largest tornadoes in the solar system occur not on its planets, but on the sun. Astronomers have long known that the sun produces huge prominences. The flashy tentacles of glowing gas that often erupt from the fiery surface. But in the last few years, new high-definition video from solar satellites has revealed prominences that turn into solar tornadoes.
They can be 5 Earth diameters wide and over 10 Earth diameters high, with winds of 300,000 miles an hour. So these are really monstrous things.
Solar prominences reach a peak when the 11-year sunspot cycle hits a maximum. The big tornadoes on the sun have something in common with their earthly counterparts.
On Earth, we have a tornado season. In some sense, the sun also has a tornado season, especially with the 11-year sunspot cycle. When we have this burst of plasma emanating in space called solar prominences, they create tornadoes of their own. So we have a tornado season on the sun.
Solar tornado season applies only to these giant monsters. The sun is also home to a smaller kind of twister. But what happens when these tornadoes swirl into action? 11,000 at a time. There is little to compare with the frightening violence of a massive tornado. The swirling funnels are spectacles of destruction on Earth. But it turns out they happen everywhere in the universe.
A tornado is an example of a vortex, and vortices are universal features anywhere you look in outer space.
Tornadoes linked to fiery solar prominences are big enough to envelop the Earth 5 times over. But scientists have recently uncovered thousands of smaller tornadoes on the sun. Small, yes, but still far larger than any tornado on Earth.
They're very different than terrestrial tornadoes that we're used to. And they're approximately 1,000 miles wide, 1,000 to 2,000 miles high.
The widest tornadoes on Earth max out 400 times smaller. The record holder is 2004's Twister in Hallam, Nebraska. This one was so monstrous, it left behind a damaged path 2.5 miles wide. But imagine a tornado 1,000 miles wide, hitting a city's buildings, packing the 6,000-mile-an-hour winds of twisters on the sun.
A wind of this speed hitting these buildings would knock them over as if the buildings were tissue paper.
The circle of destruction would extend for 800,000 square miles.
Consider Lake Erie. The tornado would simply blow the water in Lake Erie away, all of the water, in a matter of seconds. Think of the mighty Niagara Falls. Lake Erie empties into Niagara Falls. Niagara Falls would immediately dry up, and it would stay dry for weeks.
The famous falls were, in fact, once bared to view when water was diverted by a government reclamation project in 1969. But the weather on Earth has never been extreme enough to do it before. Tornadoes on Earth can be isolated events, or they can tear across the landscape in vicious swarms. The planet's largest outbreak sent 358 twisters across 21 states in April 2011. But on the Sun, there are more than 30 times that many, 11,000 at any given moment.
And these tornadoes don't have to be made out of air. They can be made out of hot gases and magnetic fields.
The Sun has so many tornadoes because it's churning with activity that sets pockets of hot gas by the thousands into swirling motions. Computer simulations show the tangle of magnetic field lines inside the gas and how the swirling action makes the gas shoot upwards, spiraling into funnels to form the solar tornadoes. The gas in solar tornadoes is so hot, its atoms are broken up into their positive and negative parts. Known as charged particles, they make up a state of matter called plasma.
When we're in grade school, we learn that the world is made out of three things: solid, liquids, and gases. Wrong. The sun is made out of plasma. Most of the universe, including gas clouds and stellar objects, are made out of plasmas. We're the freaks. We're the oddballs. We're made out of solid, liquids, and gases. Most of the universe is made out of plasma. Get used to it.
Getting used to it means realizing that most tornadoes in the universe have to be made of plasma's charged particles, trapped into twisting clouds by magnetism in space. Then, get used to the fact that some of these things are zapping our planet every few hours and literally lighting up the sky. A tornado on Earth is a frightening event. Fortunately, it's relatively uncommon. In space, however, tornadoes are happening all the time. 11,000 of them are twisting on the Sun at any moment. And astronomers recently discovered another kind of solar tornado. It's made of the thin stream of charged particles coming from the Sun, and it actually reaches down into the Earth's atmosphere, jolting it with electric current many times a day.
Space tornadoes touch down every few hours. They funnel energy down into the Earth's ionosphere, about 100 miles above our heads, actually. And they can carry up to 1 million amps of current.
That's enough current to power 100,000 homes. The supercharged tornadoes are responsible for kickstarting the breathtaking auroras we see in our planet's polar regions. But the twisters themselves are so widely diffused, they are invisible to the naked eye. It's long been known that the auroras are associated with the solar wind. The solar wind is the constant flow of charged particles coming from the sun and blowing toward the Earth.
Scientists had a problem. It turns out that if you calculate the energy stored in the solar wind, you find that it's not large enough to generate the spectacular light show called the aurora borealis. There had to be another source of energy driving the auroras.
That source of energy comes from the Earth's magnetic field. It deflects the solar wind, making the charged particles blow around the planet. On the Earth's dark side, energy from the solar wind gets stored up and then released in bursts by the planet's magnetic field lines.
These lines cross on the dark side of the Earth, and when these lines cross, they rearrange themselves, releasing a burst of energy. And that's the energy of what are called substorms.
The magnetic substorms create lots of turbulence, which generates the rotating motion any tornado needs. That rotation comes from circular whirling eddies, similar to the rings of swirling vapor that show up in the turbulent flow of a wind tunnel on Earth.
And these eddies are the space tornadoes themselves. And about a minute later, after these eddies form, that eddy, that twisting of the magnetic field line, funnels down into Earth's ionosphere, where it is ultimately responsible for the aurora.
The space tornadoes generating Earth's auroras are huge. They form more than 62,000 miles above the planet's surface, taking on a classic funnel cloud shape. Wide at the top, but narrow at the bottom, where they touch the Earth's atmosphere.
Space tornadoes out in Earth's magnetosphere are twice the size of the Earth, about 15,000 miles in diameter.
But when they touch down on the Earth, they're actually quite narrow. So you've got this flowing, swirling set of particles that looks a lot like a tornado.
But tornadoes in this near-Earth space and their even bigger cousins on the sun seem tiny compared to the twisters in the deep regions of the universe. Imagine the power of galaxy-sized tornadoes stretching across space for 1 million light years or more. The tornadoes of Earth become the oddballs of the universe when we discover there are far more tornadoes in space than on our own planet.
To get a tornado in space, you need something to be set in motion analogous to the wind, and you need some mechanism that makes them go around and spiral around, forming that funnel shape we're familiar with tornadoes.
Tornadoes on Earth are made of air, water, and wind. But virtually all tornadoes in space are different. They're made from the charged particles of plasma spinning in clouds shaped by magnetic fields. Tornadoes in space can look like this, shooting out from a star that's in the process of forming. But the most powerful are immense, up to 1 million light years long, and originating in the rapidly spinning black holes of energetic galaxies. They're known as astrophysical jets, and we see them all over the cosmos.
The jet that forms in the central region of a galaxy is like a tornado because you have a plasma swirling around a giant black hole. Within this plasma, you've got a twisted magnetic field that traps charged particles. So you've got this twisting, turning magnetic field accelerating charged particles outwards, just like a funnel that looks like a space tornado.
Tornado-like jets are so powerful, the gases inside them shoot out at nearly the speed of light. What would happen to something caught in the line of fire?
If you're in a spaceship along the path of one of these really energetic jets, you're in real trouble.
Oddly, the ship itself would not blow apart. Unlike tornadoes on Earth, galactic space tornadoes are so thin you wouldn't physically feel them. The danger comes from the incredible speed of the jet's charged particles.
Because the particles can go at 99% of the speed of light, or even more. So they're really energetic, and they're emitting lots of high-energy radiation. So you get blasted by this radiation if you don't have proper shielding, and basically you can't survive.
Survival is always in question when tornadoes on Earth terrorize us with their fearsome strength. But these swirling forces exist throughout the universe. And if power of this kind ever visited Earth, little at all would survive. As space tornadoes prove themselves to be the deadliest space weather.